Hi, my name is Dante Gagne, and I'm here to continue our series on working with the Universal Windows Platform. In this video, we're going to be talking about how you can enable device-specific functionality, like accessing the back button on a mobile device in an app that's designed to run on multiple devices, including ones that may not have a back button. Then we're going to take a look at one last technique for tailoring your app to specific devices. Now let's talk about devices for a moment. I'm sitting at my desk in my office, I've got a laptop in front of me and a Windows phone in my pocket. A Universal Windows app can run on both of them, but my phone has a back button that the laptop does not. What happens when I run my app and press the back button? Well, let's find out. For an earlier video in the series, I created a very simple app to illustrate how we can change layout and tailor your appearance to the device. Now I've got that app running here, and you'll see that I can go ahead and click this to jump to another page, and then click go back to the head page. Be nice if the back button did that on my phone, but in reality, when I push the back button, it closes the app altogether. That's clearly not what I want, so let's go ahead and get that fixed. So I'll go ahead and close that, and I've already got the app loaded here. The first thing I need is the extension SDK. An extension SDK contains all the hardware-specific function calls like the API to access the back button. Adding the SDK is easy. Just right-click References, choose Add a Reference, expand the Universal Windows node, go down to Extensions, and choose the extension SDK you need. Now there's desktop, Internet of Things, and so on, but what I need are the mobile extensions. So just check it, press OK, and after a moment those APIs will be available to me. Now let's go ahead and bring up the code behind, and let's hook up the button. Now I'm in my constructor, and all I need to do is just a traditional event handler, so windows.phone.ui.input.hardwarebuttons.backpressed. And there we have it. That's all you need to do to go ahead and get the event hooked up. Now let's go ahead and code the event handler. This one is also pretty simple. Return to main page, which is the method that I use to return to the main page. And let's just make sure the event is handled. That's all there is to it. So let me run this now on my mobile emulator. It's going to launch it on my phone. So I'll go ahead and switch to that second page. And now when I push the back button on my phone itself, it does what the go back button was supposed to do, which is move back to the header page. Great, that's all we need to do, right? Well, not quite. Let me go ahead and stop this, and let's deploy it back to my local device. If you look at Constructor, we're hooking up that event in all cases. So when I launch it on the local machine, it didn't quite run correctly this time. We've got a type load exception because what the constructor is trying to do is add an event to the hardware button.backpressed when there is no backpressed. So we need to make sure that this call only happens when we're running on a device that has a back button, or in this case, specifically the phone. Well, thankfully, the Universal Windows Platform has a solution to that as well. All I need to do is wrap this in a quick call. So what this will do is when I run it on the phone, it will check to see if the hardware buttons are present. On the phone they would be, and it hooks up the back pressed button. If I were running on my desktop, it would say that no, I don't have a back button, so it will skip over the declaration to hook up the event, and everything runs fine. Don't believe me? Okay, well, let me show you. I'll go ahead and launch this one on my local machine, and this time it's going to work. See, told you. No more type load exception, everything came up. Once again, we're working with Universal Windows apps here. One app, one set of binaries, but now I can use the functionality of a specific hardware device. That's all there is to it. Now, the next thing I want to talk about is one more piece on tailoring your app. Now, in the previous video, we took a look at adaptive triggers and the relative panel, but there's one more method for tailoring your app that I want to show you. Now, let's imagine you need to make some radical changes to your UI in response to the device. It's possible that there are just so many changes that the relative panel or adaptive triggers just aren't going to cut it. Well, the Universal Windows Platform has a mechanism to substitute some or all the assets based on the device. Take a look at this app here. If you look in the Solution Explorer over here, you'll see that I've got two extra folders, Device Family Desktop and Device Family Mobile. Now I'm going to open the main page.xaml that's in the root of my solution. And you can see that I've made it very obvious that this particular XAML is the one coming from the root directory. Now let me open the one specifically in my mobile folder. I realize that these two files are fairly similar, but what I want to illustrate here is that I have two completely separate XAML files, and now the system is going to access the specific XAML file that I want, so I've got the freedom to make whatever changes I want. So let's go ahead and launch it on the local machine. Now my application is running, and as you can see by the text, it's using the XAML that's coming from that root directory. That's kind of what I expected. Let's close that and launch it on my phone. There we are on the phone. And as you can see, the XAML file that we're using here is the one coming from that mobile directory. So what's happening under the covers is as the application is deciding which XAML files to load, just before it opens mainpage.xaml, it takes a look for a file in the specific directory name, and let me show you those directory names again, to see if there is a file with the appropriate name. So in this case, I have a folder which is exactly device family-mobile, and it has a mainpage.xaml. So when the system is about to load mainpage.xaml, if we're on a mobile device, it goes into this folder, it finds a mainpage.xaml, and that's the one that it uses. When I ran it on the desktop, it took a look in this desktop folder, which I added, but doesn't have anything in it, so naturally it doesn't find a mainpage.xaml to use instead of the one in the root, so it's going to use the one in the root. The behavior of using the one in the root would be for any platform that I didn't explicitly specify a device family-name. Now, in this case, let's take a look at the main page from the root directory, and you'll notice at the bottom I've got this icon showing all of the different devices. I'm going to go to my device family-desktop folder. I'm going to add an existing item. I'm going to jump to my desktop and choose this graphic I've got here showing a handful of desktop devices. I'm also going to change that to device.png. Why? Well, if you look in the root, you'll see I already have a device.png, and that's the file that I'm using for that image at the bottom right. Now watch what happens when I launch this on my local desktop. I've run my application, and what happened this time is the application started, it looked for mainpage.xaml, it found a device family-desktop folder, but did not find a mainpage.xaml. It went ahead and used the mainpage.xaml from my root directory of the solution, but while it was parsing that, it found an image control that was accessing an asset named device.png. This time it found a device.png in the device family-desktop folder, so it used that graphic instead of the one at the root. By using this technique, you can override individual assets all the way up to the entire XAML of your application, and you've got control over which pieces are used dependent on what device you're targeting. The real power of the Universal Windows platform is the ability to write your app once and run it on multiple devices. With the tools we've learned here, you can take your app from simply running on multiple devices to looking and functioning well on the different devices. Keep an eye out for more videos in this series, and here are a few more links for more information about developing Universal Windows apps. Thanks for your time, and from here, it's all up to you.